Okay, this is example 9 on page 55. If z equals cos theta plus I sine theta, show that z to the power of n plus z to the power of negative n equals 2 cos n theta, and that z to the power of n minus z to the power of negative n equals 2I sine n theta. That's the first part of the question, hence then we'll show these other results after that. Okay, let's start with z equals cos theta plus I sine theta. Therefore, z to the power of n is cos n theta plus I sine n theta, and z to the power of negative n, actually I might just put that there, and z to the power of negative n, just to save some room, would be cos of minus n theta plus I sine minus n theta, which is, so z to the power of negative n is, now we know that cos of negative theta equals cos theta, so that would be equal to cos n theta, and we know that sine of negative theta is minus sine theta, so that would be cos n theta minus I sine n theta. So therefore, z to the power of n plus z to the power of negative n is cos n theta plus I sine n theta plus cos n theta minus I sine n theta, which is 2 lots of cos n theta, and the I sine n thetas cancel, okay? And also z to the power of n minus z to the power of negative n is cos n theta plus I sine n theta minus cos n theta minus I sine n theta, which is cos n theta plus I sine n theta minus cos n theta plus I sine n theta, which is 2 lots of I sine n theta. Okay, now that's the first part of the question. Now, hence show those two results. So for part A, we have to show that cos to the power of 4 theta equals this expression here. Now, I'm going to call this result 1, and I'm going to call this result number 2. Now, we're trying to come up with an expression for cos 4 theta. Now, if we look here, we can come up with an expression for 2 cos 4 theta, perhaps, okay? So using result number 1 and substituting n equals 4, we've got that 2 cos 4 theta, I'm going at that, is equal to z to the power of 4 plus z to the power of negative 4. And we know that this here on the right hand side is z to the power of 4 plus 1 over z to the power of 4. So 2 cos 4 theta equals z to the power of 4 plus 1 over z to the power of 4. Also, if we look at result 1 again, so using result 1, because we seem to have come to a dead end there, using result 1, and if we substitute n is 1, we get Zn plus 1 over z to the n is 2 cos n theta. Now, if we substitute n is 1, we get that z plus 1 on z equals 2 cos theta. Okay, so we're going to use this result as well. Okay, now I'm going to start with, just leaving that for a minute, I'm going to start with 2 cos theta equals z plus 1 on z. Therefore, if we take powers of 4 of both sides, we get that 2 cos theta to the power of 4 is equal to z plus 1 on z to the power of 4. Sorry, I'm not sure if you could see that. So using that result, 2 cos theta equals z plus 1 on z, therefore 2 cos theta to the power of 4 equals z plus 1 on z to the power of 4. I've just taken powers of 4 of both sides. Now, this means that 16 cos to the power of 4 theta is equal to, now expanding this using binomial theorem, it equals z4 plus 4 times z cubed times 1 on z plus 6 times z squared times 1 on z squared plus 4 times z times 1 on z cubed plus 1 over z to the power of 4, which is z4 plus 4z squared plus 6 plus 4 over z squared plus 1 over z to the power of 4. Now what I'm going to do here, I'm going to group the z to the power of 4 terms. So we've got z to the power of 4 plus 1 over z to the power of 4 plus 4 lots of z squared plus 1 over z squared. So firstly I did those two terms, then I'm doing these two, 4z squared plus 4 over z squared, then I've got plus 6, okay? Now that is equal to, using this result here, sorry I should have not done this so early. So using this result and substituting, say n is 4, we get z to the 4 plus 1 over z to the 4 is 2 cos 4 theta, okay? So we've got that, therefore that is 2 cos 4 theta. Now also looking at this result, so what we're doing is subbing n equals 4 into 1 and n equals 2 into expression 1 up here. Okay, so we've got z4 plus 1 on z4 is 2 cos 4 theta, and 4 lots of z squared plus 1 on z squared will be 2 cos 2 theta. So we get 4 lots of 2 cos 2 theta plus 6. Now we can therefore say that 16 cos 4 theta is 2 cos 4 theta, that's to the power of 4 theta, plus we've got 8 cos 2 theta plus 6. Now dividing through by 16, cos to the power of 4 theta is 2 over 16 cos 4 theta plus 8 over 16 cos 2 theta plus 6 over 16. Sorry, just running off screen there. So I've just expanded here. And then I've got 16 cos to the power of 4 theta, then dividing through by 16, and we end up with, now I'm going to take out, I need 1/8 actually as a common factor, but what I'll do, I'll take out, remember 2 on 16 is 1/8, so I've got 1/8 cos 4 theta. I want to keep the denominator as 8, so I'm just going to halve these both, plus 4 on 8 cos 2 theta, and halving these both, plus 3 over 8. And now pulling out 1/8 as a common factor, I get 1/8 cos 4 theta plus 4 cos 2 theta plus 3. And that's the result for part A as required. Okay, now going to look at part B. Now in part B, we've got to show that sine to the power of 5 theta equals this expression here. Now we'll use expression 2 here, z to the power of n minus z to the power of negative n is 2i sine n theta, to work on this result here. So I'm just going to write that over here. So using this result that z to the power of n minus z to the power of negative n is 2i sine n theta. Now when n is 1, we get z minus 1 over z is equal to 2i sine theta. So therefore, again, we've got 2i sine theta equals z minus 1 on z. If we take powers of 5 to both sides, we've got that 2i sine theta all to the power of 5 equals z minus 1 over z all to the power of 5. Now we need to expand this. So on our left hand side, we've got 32i to the power of 5 sine to the power of 5 theta equals z to the power of 5. Remember, we're going to use Pascal's triangle, which is 1, 5, 10, 10, 5, 1. They're the coefficients. But because we've got z minus 1 on z, the first term's positive, then the second one's negative, then we've got positive, negative, etc. So we've got minus 5, bring this power of z down by 1, z to the 4 times 1 over z. Then we've got plus 10, z to the power of 3 times 1 on z squared. Then we've got minus 10 again, z squared times 1 on z cubed. Then we've got plus 5, bringing this power down by 1 and increasing the denominator by 1, plus 1 over z to the power of 5. Sorry, minus. Remember, it goes plus minus when you've got z minus. Okay? So simplifying that, we've got z to the power of 5 minus 5 times z cubed plus 10 times z minus 10 over z plus 5 over z cubed, because z on z4 have a denominator of z cubed, minus 1 over z to the power of 5. Now, putting the same powers together, we've got z to the power of 5 minus 1 over z to the power of 5. Then we've got minus 5, so that's our first lot, minus 5. I've got z cubed. Now to get a plus 5 on z cubed, I go minus 1 over z cubed. And so we've done that with that, we've done this with that, and then we've got these two. Plus 10 z minus 1 on z will give me 10z minus 10 on z. Now, using part 2 and substituting n is 5 for the first one, n is 3, and n is 1, we will get that that is equal to, now z to the power of 5 minus 1 over z to the 5 is 2I sine 5 theta. So it's 2I sine 5 theta minus 5 lots of 2I sine, this will be 2I sine 3 theta if n is 3, and plus 10 times 2I sine 1 theta, so 2I sine theta. Now that's what 32I to the power of 5 sine 5 theta is. Now we know that I to the power of 5 is I squared times I squared times I. Now I squared times I squared is negative 1 times negative 1, which is positive 1. So therefore this is 32I sine to the power of 5 theta. Now that equals 2I sine 5 theta minus 10I sine 3 theta plus 20I sine theta. Now if we divide through by 32I, we get sine 5 to the power of 5 theta is 2I sine 5 theta over 32I minus 10I sine 3 theta over 32I plus 20I sine theta over 32I. Now the i's cancel, and simplifying these fractions, if you're looking at the result that we're trying to get 1 over 16. So simplifying this, we get 1 over 16 sine 5 theta, because the i's cancel, minus 5 over 16, i's cancel, sine 3 theta, plus, just going to divide these both by 2, 10 over 16 sine theta. So therefore, taking out 1/16 as a common factor, we go 1 over 16 sine 5 theta minus 5 sine 3 theta plus 10 sine theta, and that is our result. Sine to the power of 5 theta equals that expression there as required.